Hi, I'm Ben. I'm the TL of GAPID. This is Pascal, who's also been working on it almost as long as I have. So this slide's probably a little bit irrelevant now. GAPID, it's an open source, developed in the open, trace and replay tool for GLES and Vulkan. It's currently a debugger. It can be used to diagnose and fix many graphics issues when developing games. We've been using it in the field and have found some very stupid things that some of the games engines are doing that otherwise would be completely hidden from the developer. It is cross-platform. It runs on Windows, Mac, Linux, and we can use it to trace any debuggable Android application. For Vulkan, we actually also support desktop, so you can trace any Vulkan application on Windows or Linux, obviously not Mac. And yes, you can go and download it right now. It's on GitHub, so github.com/google/gapid, and then you can take a look at the releases. So instead of just talking about it, it's graphics after all, we might as well show some stuff. So take over to Pascal.
All right. OK, so when you first launch it, you will see this welcome dialog that lets you quickly do your most common actions, like capturing a trace. If I can see the mouse. And there's a capture trace dialog. You choose which API you'd like to trace. And you trace OpenGL, or you can choose your Android device. And because we're running out of USB ports, we're not going to actually do a trace. It's also pretty boring. You choose your APK, your file names, and you have some options, and you can trace file. But instead, I'll just open. Oops, if I can. Open a trace we've taken previously. This is a trace of one of Google's only games, Sushi, on Android. Up the top, you can see the frames that were captured. We see some frame previews of the frames. This is mostly just a menu. Let's see if we can find something more interesting. Yeah, so the beginning of the application. And on the bottom, on the left side, you see all the commands, and we group them nicely by frames and draw calls. And if you include debug markers in your application, you'll see debug markers, which you will see right here. You can see all the groupings. This is tiny for me to see. For example, we can look at. And you could step through your frame and see how it gets built up. You see all the draw calls that are grouped here. And of course, you can see the actual GL calls as well that went into this draw call. But obviously, we want to also show you some more of the rest of the state of the GL driver. So for example, we can look at the geometry that was rendered here. So this is just some leaves, but let me pick the shrimp sushi here. You can see a little more interesting geometry. And you can, for example, debug your normals if they don't look OK, things like that. You can inspect the geometry that was rendered in this draw call. And we also allow you to inspect all your textures. So you see some textures that were used. Let's make this a little bigger here. And this also will show you contents of texture that are render targets, so which is really nice. You don't need to render your shadow map on the screen. You can just inspect it here. And you have some image tools, like you can disable channels, which is, again, helpful for shadow maps where you have different values in different channels. And yeah, you can zoom in and inspect the textures. Of course, we also show you your shaders. And one of the things we'd like you to be able to do is rapid prototyping. And whenever you have like an issue in a shader and you're adding a shader, right? You add your shader, you save it. You have to rebuild your application, and then you have to package it up, deploy it to your device, run it, just to find out that you forgot that .0 or whatever. So we allow you to edit the shaders in place here. So let me just paste something in here that I've saved before. You push your changes, and within a few seconds, you can see the changes that happen, and changing our skybox here to be a nice sunset red, and you can see that it has changed on all frames. We've changed our little skybox to be nice and red. we track the entire state of the GL driver, so you can inspect it at any point in your trace. You know, if you see an issue and you want to know what was the blend state at this point in trace, you can go in and inspect the trace. And, you know, you can see the blend state, for example, right here for Framebuffer 0, and you see all the values that you've set, and you go, oh, yeah, no, this should be something different. We also have a beginning of a reporting system that tracks errors, for example, GL errors. If there's a GL error during the trace, we'll show it here, for example. Here there's an error, and you can quickly go to the command and see that this get integer has an interesting identifier that doesn't exist. And we're also planning on having other things that we can detect in your trace and give you actionable feedback on how you can improve your game. I think that covers about most of it.
Could show the memory.
Okay, yeah. Obviously, for some commands, you know, like let's just find something like GL uniform. It's not exactly very interesting to see the memory pointer. So we also obviously track the memory, and you can see what memory was passed in, and you can format it in the correct value. So here you can see the matrix that was passed into this uniform. Yeah.
So the memory is a sort of power tool, but for any particular command that you select, you can see all of the memory that was read or written by that command at that point in the trace. Just being handy for sort of off-by-one errors. So yeah, that's pretty much the tool at the moment. A couple of other things. We support multiple contexts for GL. The bar at the top there, it by default selects what we consider the most relevant context for the particular game. But for a lot of the engines, there's multiple contexts that are spun up, so you can look between them. There's an option as well for an interleaved context mode, so that you can see how the contexts are talking to each other. But yeah, that's pretty much what we have right now. If there's any questions, by the way, please feel free to interrupt.
Yes.
Sorry?
Is there like a high-resolution CPU timestamp on this? Sometimes it's nice to know what your code's doing CPU side when it's building the frame.
Currently, no. We did want to put extra metadata in, like timestamp information. We're kind of on the fence about the usefulness of that, because when you do take a trace, times are skewed. So having sort of real-time information can be a little bit deceptive. But things like stack trace information would be particularly useful. Just seeing a particular draw call that's bad, where did that come from? Yeah. So yes. Again, if you have these suggestions, please forward them to us, and we'll act upon them.
Does the frame rate view show the current render target that's bound, or is it showing what's going to be the back buffer?
The frame buffer view shows what is currently bound at that point in the trace.
Okay.
So, yeah.
Yeah, if you have post effects and things that are going on off screen, you can debug all of them.
Maybe I missed it. What's the requirement for the GPU and the Android OS supported now? Does it work on all GPUs? On which Android versions?
Okay, so in theory, it shouldn't really matter. The way that we intercept at the moment is by patching the driver. And there are some limitations on what we can patch. So we require a certain number of bytes of instruction per function that we're trying to tamper with. And on certain drivers, there are functions that are too short. Coming up in a new version of Android, coming to you soon, is actual OS support. So we won't be doing this nasty driver patching. We will actually have hooks in the OS, so we can trace anything.
Hello. Is Framebuffer Flex on Pixel local storage extension supported for?
We can examine depth at the moment. We haven't got a view for stencil, but yeah, we'll be working on that soon.
That's pretty useful for us. Sorry.
Okay. So speaking of what we're doing, before that, just to mention that the tool is pretty modular. We have all of the sort of bulk of the smarts in one particular process, and the UI isn't actually tied into that at all. We have an RPC interface that the UI uses to talk to the server. And we have another tool that we actually ship when you download it. It's called GAPID, and it actually exposes a lot of the same functionality. It's been really useful for us developing. You can use it to examine commands, states, frames, and use it to try and find GL errors or Vulkan issues. And we see a lot of value in this in automated testing, in that you can take a trace, you can use the command line tools as part of your nightly builds, for example, and find issues in your application that would otherwise go missing. So just to give an example, I'm not going to type up the command line, but yeah, given the same trace that we were just demoing, you can get a screenshot at any particular points. We also have the ability to create an MP4 video of whatever you have. There's also another mode that we have where we will capture the frame buffer while we're tracing. And then when we come to do a validate, we can actually check that the replay matched. When we have on-device replay going, that could be particularly useful for variations between drivers, for example. Oh, and my slide failed. Yay. So the current work that we're doing at the moment, for those of you that may have tried GAPID already, you may have been disappointed with the performance of the tool. We are fully aware that it isn't as fast as it should be, and it takes up too much memory. So this is our #1 thing that we're working on right now. Make it faster, make it less resource hungry. Mid-execution capture for GLES is what we've heard people want lots and lots, so we're going to try and get that out very soon. And on-device replay. As we briefly mentioned, I've actually used up all the USB ports on this machine. The replay for GLES is being done on this machine. So we translate from GLES to desktop GL for replay. We've taken that about as far as we can. Apple refused to push GL drivers any further than they are. And we're now at the state that GLES is actually exceeding desktop GL that they support. So on desktop replay, just through translation, is actually becoming difficult to impossible. For Vulkan, same thing, performance. We also want to get the validation layers in as part of the report. So you don't have to have the layers in. You take a trace and you get all the same information out. And the final one is an improved UI for visualizing Vulkan data. Vulkan is a very different beast from GLES. It's not immediate mode. You've got command buffers. Trying to display things as a linear sequence of calls is one way of doing it, but it isn't the best way that we feel. So we're doing a lot of research at the moment in how to better visualize these new graphics APIs where you have more of a graph representation, maybe. So after that, we have a large collection of ideas of things that we want to do, but we want to get feedback from you on where we should be investing our time. So I've been leading this project for a number of years now, and as a teenager, I always used to play RTS games far too much. So tech trees are kind of the way that I visualize my job, in that there are many things that I could be doing, and certain things unlock other things. And so the rest of these slides are going to be going through some of the things that we can do and how I categorize them in my crazy gamey brain. So there is a questionnaire that you can fill in as we're going through this. It might be helpful to play along, just so that you know what I'm talking about when you have a question. If you don't want to, that's fine. I won't hold it against you. But yeah, if you can open that, please go ahead, and the slides will relate to the questions that come through. Cool.
There's a question.
Question?
there any timeline for a graphics profiler for the GPU?
Timeline? We'll see what the feedback is from today, and we might be able to get a timeline from that. Cool. So the first group here is statistics. I kind of classify things that don't involve profiling, but still have meaningful values under this group. So the simplest one, which we probably should have by now, is the sort of X per Y stuff. So this is number of draw calls per frame is like the most obvious one. You're doing 2,000 draw calls on a device that can only cope with a few hundred, you're going to have a bad time. So yeah, examples of this are obviously draws per frame, vertices per draw, triangles per whatever. Estimates on memory usage as well, like, number of megs of textures that you have. We also want to come up with some sort of device budgets. Part of my work over the last year has been going out to games companies and trying to help them get their games reaching 60. And yeah, sort of based on the X per Y thing, the number of titles that are being developed without any kind of reasonable guidelines on how many draw calls you should be making for a particular device is a little bit depressing. So we could offer up some sort of data that for a particular flagship device, we recommend that you submit X number of vertices per frame, for example. We could have inside GAPID automatic knowledge of a collection of different devices and give you warnings if it notices that you're way outside those budgets. Framebuffer visualizations, these are things like number of overdraws that you're doing. We can also include things in here like the number, well, highlighting the fragments that may have failed a depth test, which would be a good thing, or displaying the frame by shader program, for example, which is a great way of knowing where you should be looking at optimizing your shaders. Shader static, oh. Yep. Yeah, overdraw is part of that. Yeah. It's coming. Okay. Shader static analysis. So this is a tricky one. It would have to be a sort of finger in the air one because, there's many different GPUs out there, many intermediate layers between your shader code and actually what the shader is doing, the hardware is doing. But yeah, we could come up with some rough estimates of number of ALU ops to text, for example, which can be helpful in just getting a sort of hand-wavy estimate of what your shaders are doing. Profiling, big feature request here. So classic, first thing that people think of is frame and draw counters, I've said. But yeah, frame and draw time would be great. Unfortunately, tiled architectures make draw call times very difficult. We've got a few ideas on how we might be able to come up with some data that would be useful. But yeah, knowing what your frame rate is like or how long, knowing how long certain things are taking is definitely something that we want to do. If we can also get hardware counters from the IHVs, we would like to try and massage those huge seas of hardware counters that nobody really understands into something meaningful, so that we could tell you, how much time you're spending doing texture fetches, how much time you're cache missing, for example. Something that a lot of the IHV tools offer over things like draw call times is relative shader costs. So while their tools may not be able to tell you exactly how long a single draw call took, they take more of the approach that these are all the shader programs that you have, and this particular one actually takes 30% of your time, so it's where you should be optimizing. This is something that I think is very valuable and we should definitely have. So assuming that we get the first two done, we would love to have metrics-driven suggestions. So if you've used other tools before in the past, they often suggest, have you thought about changing your vertex format so that you interleave as opposed to have them separate? These are things that we would like the tool to actually go and do for you. If we have a bunch of patterns that the tool can actually detect, apply them to your trace and time them, we can offer a sorted list of things that you could do to optimize your game, ordered by impact. I understand that games developers, their time is precious. You don't want to be spending 3 days trying to optimize something to get 0.5% improvement. If we can show you that doing this one thing will save you 10% of your time, we should do it. Another thing that's often forgotten is power usage and thermals. But yeah, it's really important. So if we're going to give you any profiling information about timing, we should also be looking at how much power you're using and see if there's anything that we can do to suggest reducing that. Shader debugging. Being able to click on a vertex or a fragment in your frame buffer and have single line stepping. So this is pretty bug basic, but yeah, we want to be able to let you step forwards and backwards, have a watch window, see all the values as you go along. There's a big question here as well about whether you would value more a simulation versus real hardware. There are pros and cons to both. If you're trying to debug something and you're getting a black pixel and it's a driver or hardware issue, then obviously having a reference form of that might prove to you that it actually is a hardware issue, whereas trying to pull back from the actual hardware might give you skewed results in its own way. Pixel history is kind of part of the debugging, but clicking on the frame buffer, seeing all of the draws that influence the color or depth or stencil, and maybe including or excluding ones that have since been overwritten. A table of shader ins and outs. This is more common for vertex forms, that if you've got one crazy vertex that's 1/2 mile across the screen, you can identify that single thing and then go and debug it and figure out why you've got an imp or an an or something. And something else that we thought about that would be very nice is if you're debugging a particular shader, highlighting the inputs and outputs. So if you've got textures, for example, that you're sampling in your shaders, actually highlighting the fragments that are involved in that particular shader run. Assuming we can do it, it would also be very nice if you had sort of anisotropic filtering, showing all of the fragments that are actually being used. And then finally, we come on to the reference rasterizer. So kind of touching upon what I was saying, that we have taken the on-desktop replay about as far as I think we can take it. We're now looking at alternatives. So a reference rasterizer could be very useful for other things, as well as having a guaranteed replay that you can do on your host machine. Now, the first one is that we know that devices do have issues. Drivers can be buggy, hardware can actually be faulty. And we really want to hear about this. We can't stress enough how much we want to hear about broken drivers. We know that people are having a bad time, but we have to go out and ask you a lot about your stories. So if you had a trace and you take it and you're idle, we think that we could do a replay in the background with the reference rasterizer and actually check that what you are getting replayed on the device matches what we think it should be. And if they are not the same, we can offer you a one-click report a bug. That gives us an exact repro that we can give to the driver teams to fix that. So it would be a nice way for the Android ecosystem to be better all around. GLES and Vulkan, they are specs that have sort of hand-wavy aspects to it, especially around floating point precision and sampling. If we have a reference rasterizer, we think that there'll be value here in having some knobs that you can fiddle with to basically compare how things would look on different sort of hardware specs. So the floating point precision is the classic one. If you lowered your floating point precision, do your shaders then suddenly start dividing by 0? This is something that happens, and something that maybe we could catch for you automatically and alert you. On host replay, we've got it for GLES. We would like it for Vulkan as well. But yeah, reference rasterizer makes that definitely possible and more solid than what we have at the moment. And then finally, the automated testing thing. So this kind of goes back to the GAPID tool. If you have a ref-rast and you've got, say, nightly builds that you're doing, you could just basically have GAPID automatically take a trace of your game. Make sure that you've got no bad usage of the graphics APIs, and you can also use it to get a reference video of what the game should be looking like, and also use the tooling to actually get videos across the different devices that you care about and potentially flag them as issues as they crop up, as opposed to in the last week of getting the game out the door. So that was a lot of stuff that I just covered very, very quickly. If there are things that I've missed here and you think are very valuable, please, please, please let us know. And that's it. Any questions?
You talked about the power profiling.
Sorry, microphone.
You just mentioned power profiling. Could you elaborate?
It's still very much research at the moment, but the idea is that we could have the ability to replay the same frame repeatedly. And if we had hardware support for actually seeing the drain and monitoring the thermals, we can at least come up with if you keep on having your game render something similar to this particular frame, this is the kind of characteristics that you're going to have on the battery and thermals. And any of the heuristics that we have for optimization, we can also try that as well. It might be something that you would have to run overnight to try and get stable results, but it's better than weeks and weeks of poking around yourself.
You put the URL back up with your questionnaire.
Oh,
Thanks.
sure. Go, go, go. Finger hurts. There we are.
There's one over here. There's one over here. Thank you.
For the power and thermals, is there going to be any way to tie that back to the core frequencies and the CPU usage, so you can see whether or not there's a trade-off between your submission of the call time versus the actual GPU time?
Great suggestion. Yeah, maybe. These are things that we have briefly looked at. We haven't started development on. So yeah, if that's valuable,